Okay, the review. So, tomorrow's quiz should follow the same kind of format. The graph might be a little bit different. Some of the problems might be different, but it's basically the same thing. Okay? So let's go through it. Starting with number one. Okay, this is what I want. Nobody should miss number one. Define a function. It's where every element in the domain is paired to exactly one element in the range. Okay, basically in fancy words it's saying that every x value has only one y value, right?
Can you say that?
Nope, I like it this way. Let's be sophisticated mathematicians, okay?
Okay.
Because here's why, Gerardo. Not every problem has to do with x and y. For instance, a problem might have to do with distance and rate, or time, right? Or objects, maybe a position of an object. Does that make sense? So that's why you have to have your domain, which might be time, and your range, which might be distance, right? You can't be in two places at one time. Hey, there you go. Can you be in two places at the same time? No. Wouldn't be a function, would it? Okay? All right. Example 2. Here we go. So if f of x equals x cubed minus x, find f of negative 2. So all we do is just plug that in. So f of negative 2 is simply going to be equal to a negative 2 cubed minus a negative 2. And I do encourage you to use a calculator. There's nothing wrong with calculators. If I just plug this into my calculator just like that, I go parentheses negative 2 to the third power, okay? Subtract parentheses negative 2. You just have to be careful on your negatives and your subtractions, right? But you can put it into your calculator. Boom, there's my answer, negative 6, okay? Make sure you can get negative 6. Not too bad. Okay, number 2, we just plug in 0, or I'm sorry, B. Just plug in 0, so that is going to be 0, but I'll do the work. F of 0 is really, 0 cubed minus 0, but I can do that math. I don't need a calculator, right? That's just 0. Thanks, Alondra. It is just 0. I would agree? Now, C is different. C is different. C says it's equal to 0. So you don't plug in 0, but just set it equal to 0, okay? So I'm going to take f of x, which is my x cubed minus my x, and set it equal to 0. Okay, now I have to solve. There will be, you ready? 3 answers because of the x cubed. You're going to get 3 answers because of the x cubed. So Carmen's like, how do I get 3 answers? Hey, do you remember how to factor? Anybody remember how to factor? What do they have in common? They have an x in common, right? If I take out the x, I have an x squared minus 1. Okay, right? And then what could I do from here? I could factor the x squared minus 1 into x plus 1, x minus 1. How am I doing, okay? So then if I were to solve for x, I'd have x equals 0, right? So one answer is 0. I have x plus 1 equals 0, so that would give me a negative 1. If I took this and solved for x, I'd be a negative 1, right? And I'd get a positive 1. Now we're also going to graph it. You can see in 3. We're going to graph it in 3, and you're also going to see those 3 answers on our graph, okay? So I do this, we're doing the exact same problem again, but we're going to take a look at it graphically, okay? So we should be able to get all 3 of these answers from our graph, okay? All right, you ready? So number 3, let's graph it. So first of all, let's put it in the calculator, right? Am I going slowly enough?
Yes.
Okay, so I'm going to go y equals, and I'll go an x to the third power minus x, okay? Probably a normal window. I might have to adjust it, but if you're thinking negative 10 to 10, negative 10 to 10, my normal window, right? And then we'll take a look at it, and then if we need to adjust the window, we will, okay? So already graph. Okay, so I might adjust it because I can't really see what's going on in here. So to adjust here, I'm going to squish my y's, and I'm going to squish this. So when I start to look at my window, I'm going to go back to this little statement here, okay? I only want to see it from negative 3 to 3.
So we would go in and change both.
So the window, I'm going to go negative 3 to 3, okay? Is that right? Okay, negative 3 to 3. And for the y, I wanted to bring down the y also, so let's go negative 3 to 3 on the y also. Okay, how's that? How am I doing?
There we go.
So now if I graph it, all right, that's a better look at it, isn't it? Right? Everybody have a picture that looks like that? Okay, so let's go back to the zeros. Okay, if I have back here fx equals 0, that's a 0. That's a height of 0. Where do I find that? Sure enough, there's a negative 1, 0, and 1. So if you could not factor this, if you had a hard time doing C, and factoring was like something foreign, like a foreign language, you haven't seen it, Brooke. You haven't seen math in about 2 years, have you, Brooke? But you could get it off the calculator, right? There they are. Negative 1, 0, and 1. Okay, so those are zeros. So let me get a piece of graph paper out, and I'm going to try and graph this so I can make it look nice. So I want to do a really good job of graphing it. So take a ruler, and I know this much of it. I know that I'm going to go negative 1, 0, and 1, and I'm just going to give a rough sketch of it right now, and then I'll do a lot more with it in a bit, okay? How's that? So far, so good? Okay, so far, so good. Now, what are some of the things we can find? Well, we can find our max and our mins, right? So I'm going to use my calculator to find the max. Remember, where do we find the max at?
Second calc.
Second calculate, right? And let's find the maximum. So my maximum. Left bound, so I go to the left-hand side of that maximum. So family maximum is right there. I just went to the left-hand side, okay? It's blinking, so I want to lock it in, so I push enter. Okay. Right-hand bound, so I'm going to bring it over here. Okay. It's blinking, so I'm going to lock it in, push enter. So now the calculator knows where to look. It's going to look in between here. So I push enter again, and it tells me that it's at negative 0.58. We'll make it negative 0.58. So negative 0.58 and about a 0.4 maybe. Okay, that's going to be my maximum. That's that little point right there, okay? How am I doing? Thumbs up? Okay. So let's find the minimum. So same way, second, calculate, let's go to the minimum. Okay. How am I doing? Okay. And it wants a left bound, so I'll go to the left-hand side of my minimum point. Minimum point's right about there. Lock that in, enter. And enter. Guess, right about there. So I get about a 0.58, positive 0.58, and about a negative 0.4. Okay, it is symmetrical, so it kind of makes sense you'd have just the opposite values. Okay, now, so I've got my max, so I got my local max, I've got my local min, so my local max is at negative 0.58, 0.4. My local min is at positive 0.58 and a negative 0.4. All right? Okay. Let's get something easy. Let's go all the way and get the zeros right off the bat. You guys see the zeros? Let's get the zeros. So the zeros, we've already solved them, right? Exactly. We know the zeros are, it's where it has a height of zeros. That's why they're called zeros, because their value is 0, okay? So where's my zeros at? Negative 1, 0, and 1, right? Zeros are at negative 1, 0, and 1. How's that? Or you can write them as points, negative 1, 0, 0, 0, or 1, 0. I'll take either answer. As long as you can get those three values, I'm happy, okay? How am I doing? So far, so good? Now, increasing, decreasing. So, first of all, I need two other points. Are we listening? I need the point way up here, and I need the point way down here, okay? Because I'm only going to look at this thing between, in fact, I'll block it out. I'm only looking at this much my graph. I'm only looking at it between negative 3 and 3, all right? So that's the only part of the graph I need to look at. I don't need to look at anything else, but I want to find out what these values are. So the easiest way to do that is to go to my trace button, okay? So if I just go to my trace button, go to trace, and let's try negative 3, negative 24. So it's way down there, but, you know, we'll just put it as negative 3, negative 24. Okay, want to do that again? Show you the trace button.
Yeah.
So if I go to trace, trace is there, 3, I get a positive 24, okay? Positive 24. So I get a point at 3, 24. Another way you could do it, another way is just plug in 3 into the equation, right? I can plug 3 in and get an answer, or I can plug negative 3 in and get the answer, okay? So you can either plug it in, or I think it's easier just to trace, right? Because I'm lazy. I'm not really lazy. I'm just like rather be smart, right? Let's use the easiest way. Okay, now that's going to help me with domain and range. Now domain, you cannot miss domain. You cannot miss domain. Everybody listening? Domain, that is domain. That is your domain. That is your domain. Because we're only looking at it between negative 3 and 3. Does that make sense? That's our domain. Remember, don't mess with your domain. How wide is the graph? My graph is only this wide. So the domain is simply going to be negative 3 to 3. Don't miss that tomorrow. That's such an easy one. Now the range, since we already figured out what these points are, what's the very lowest point on this graph? Negative 24 is my very lowest point. What's my very highest value?
Positive 20.
So my range is just going to go from a negative 24 to a positive 24. Oh, sorry, bracket. Negative 24 to positive 24, bracket, because it's an interval, okay? Thumbs up? Okay. Now, here's one that kids have a real hard time on, okay? But we're not going to. It's going to be easy for us. Increasing, decreasing. All right, let me see if I can get a different colored pen here. Increasing, decreasing. All right, I got a red one, okay? So the graph is going uphill, right? Increase, going uphill all the way to here, right? You guys agree with that? It's increasing, but we don't want the x values, okay? Increasing, write this down. Increasing, please write this down. We want x values. If you put down points, I wouldn't take it wrong, but we're increasing from negative 3 to the top of the hill. To the top of the hill. Now the top of the hill is at 0.58, okay? At
Negative 0.58.
Thank you, Marie. Negative 0.58. And I'll put a parentheses. If you mess up the parentheses, don't worry about it. But if you're at the top of the hill, you're neither going up nor down, right? When you're at the top of the hill, you're neither going up nor down. So at the top of the hill, you're there, okay? Now it's also increasing from, you ready? It's increasing from here to here, right? Okay, see it's going uphill from here to here. Again, we're looking for just the x value. And, or, we're going to say it's also increasing from, this is a positive point, parentheses, positive 0.58 to a positive 3. Now it keeps going up forever and ever, never, 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 but we're saying just within this interval. Can you guys see? How's that? Okay, that's the tricky one. So I'm just saying, from here to here it's going uphill. From here to here it's going uphill, right? What are the x values? From here to here, as you slide over, it's going up. As you slide over along the graph, it's going up. So when you go from negative 3 to negative 0.5, it's going uphill. As you go from 0.58 to 3, you're going uphill, right? You're increasing. Now what about decrease? Where is it going? Downhill?
From negative 0.58.
Totally right. Totally right. Yep. So decreasing, we want the y values again. Decreasing. We want the x values. X values. Marie is right. It goes from a negative 0.58 to a positive 0.58. Are the x values where it's going downhill, okay? That is usually the place where most kids mess up on this test, but you're not going to mess up tomorrow, are you? Okay, you're going to be good. Thumbs up. Thumbs sideways. Thumbs down. Okay. Or no thumbs at all, huh? Okay, let's take a look at the next one. All right, number 4, piecewise graph. All right, so to do a piecewise graph, let's go ahead and draw it in. Okay. Oh, I gotta go all the way up to 9, so better make it nice and big. So when I do the piecewise graph, the first thing I do is I put in my border points. Okay. These are my borders. Yeah, okay. These are my border lines. Okay, these are my border lines. Okay, am I going slowly enough? Okay, my border lines. These are x values. Okay, there's my x-axis. These are x values. So my border lines are going to be at negative 5. 1, 2, 3, 4, 5. Negative 5. I'll have a borderline at negative 2. I'll have a borderline at 3. And I have a borderline at 5. Okay. So I'm going to have three pieces. I'm going to have three different graphs pieced together within these borders, okay? And I just draw a borderline, okay? You can put it in. They are not part of the graph, but it just helps me if I draw them in, okay? So there's my border lines, which gives me my regions, okay? So within these regions, I'm going to put these three graphs, all right? So the first graph goes in the first region between -5 and -2, okay? So the very first graph goes right in here. So what is the first graph? Remember, f of x and y, same thing, right? So the very first graph is really y equals 5. Well, y equals 5 is a horizontal line, right? So I go up to 5, 1, 2, 3, 4, 5. I just draw it straight across, okay? Now I could draw the whole thing, but I'm going to have to erase anyway, right? Draw the whole thing all the way across, but this piece only belongs within this region, okay? This graph, y equals 5, only belongs in there, okay? The second one, 9 minus x squared is a parabola. This is a parabola, so I'm going to have a y equals a 9 minus an x squared, but it's an upside down parabola because of the negative, okay? Be careful. Tomorrow it might be right side up. You just don't know until you see it, right? So let's start up at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the way I taught you how to graph a regular parabola is just squared numbers. 1, 1, 2, 4, 3, 9, because 1 squared is 1, 2 squared is 4, 3 squared is 9, right? So if I start here at my vertex, if I go over 1, 1 squared is 1, but it's negative, so I go down. It's negative, so I go down. Go back to your vertex, go over 1, 2, 2 squared is 4, so I'll go down 1, 2, 3, 4, okay? Go back to your vertex, over 1, 2, 3, 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, puts me right there. And of course, parabolas are symmetrical. Now, you can also put this on the calculator, and I'll show you that when I get done, okay? I will, but you have to be a little bit more accurate, okay? So then, I'm just going to connect the dots. And I'm only going to graph that piece. The parabola does go forever all the way down, but we only want that piece. This particular parabola only exists between -2 and 3. That's it, okay? It would go all the way down, okay? Last graph. Last graph is a y equals an x minus 3, okay? So that's a straight line. That's a linear function, so I'm going to start at -3. 1, 2, 3, right? I'm going to start at -3, then I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, right? So the graph looks like this. That's my line, but I am not going to keep all of that. I only want a piece of it. And the piece I want exists between 3 and 5, right? So I only want this piece of it right here, and I will erase what's left over, okay? Now, there's my graph. It's pieced together. Not bad. Let's answer the rest of these questions. So state the domain. So how wide is this graph? This graph goes from -5 to 5. Also, the domain is always going to be from this one to this one. That makes sense, doesn't it? The domain is always going to be that one to that one. -5 to 5. So my domain... Yeah, sorry. Yeah. So my domain is going to be from -5 to 5. Okay? The range. What's its lowest y value? What's its highest y value? There you go. There's your range. Reach for your range, right? Those are your y values, okay? Now zeros. It has only one zero. Zero is where it crosses the x-axis. Sometimes they don't. In fact, you'll have 2 different quizzes tomorrow, and one of the quizzes doesn't have any zeros. You'll just have to wait and see if you get that one, okay? One of your quizzes has no zeros. The other does. So this one does have a 0. Our 0 is at x equals 3, okay? That's my 0. Because at x equals 3, you have a height of 0, okay? Can you do this tomorrow? Thumbs up. Sideways. Down. All right. Okay, and it's being recorded too. You can watch it again tonight, okay? All right. Example 5, domain. Before we do any domain thing on these, we got to write down 2 important things. Okay, one, first of all, on domain, never divide by 0, because that will make Cookie Monster sad, right? And never have a square root of a negative number, okay? Oh, hold on. Before I finish 4, I did want to show you that you can see it on the calculator, okay? All right. So, real quickly, I want to show. Let me go back to normal window. Okay. Hold on. Y equals. All right. Okay, real quick, before I finish number 5, because Lane, I know you like the calculus, right? So you go y equals 5, first equation, right? 9 minus x squared, second equation, right? And then x, subtract 3, right? And then you graph it. The only thing you have to do, you can get all 3 graphs. Do you see them? So if you can get all 3 graphs in the calculator, you just have to know where their boundary lines are, right? Is that helpful? If you put it in the calculator, you can see, here's our first graph. It goes along like this, down, and then up, that little piece right there, okay? Okay, that might help you too, okay? All right, back to number 5. Okay, so first of all, I'm going to factor the first one. I'm going to factor this first one, and I'm going to rewrite it as 3 over x times x minus 6, okay? So there are 2 x values I have to be afraid of. 2 x values. 2 x values that Cookie Monster is going to be sad. One is if x is 0, because I'd have a regular 0, you'll divide by 0. Do you see that? If x is 0, that's bad. X cannot equal 0. So we're going to say x cannot equal 0. And 6. Because 6 minus 6 is 0. Does that make sense? 6 minus 6 is 0. So x cannot equal 6. But x can be everything else. So here's your domain. It's these restrictions and x equals all real numbers. So it says, this says x can be everything and anything all over the place except these 2. That's what my domain says. Now if you graphed it, I don't mind showing you on the graph. So if you graph this, clear, 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 and you did a 3 divided by parentheses, x squared, subtract 6x, right? I graph this. If I take a look at my calculator, there's some weird things going on at 0 and at 6, aren't there? There's some asymptotes going on. We'll learn about asymptotes later, okay? But there's an asymptote at 0 and at 6. It's going crazy because it cannot equal 0 or 6. Okay, B. It's a square root graph, okay? If x was 4, it's okay. X can be 4, but x cannot be 5. X cannot be 5. Because if x is 5, what's going to happen?
Negative number.
X can't be 6. X can't be 7. So x has to be less than or equal to 4. X must be less than or equal to 4. It cannot be 4.1. It cannot be 4.5. It can't be 10. It can be 4 and less. Now here's another thing. Let's say we graph it. I'm okay if you guys, if it helps you to graph it. Graph square root of 4 subtract x. Let's check this one out. Graph. Boom. So domain is really what x values. We look at the graph. It looks like it starts at 4, goes back, right? Less than or equal to 4. So the calculator can do a lot of this, but you have to understand what domain means. Thumbs up. Thumbs sideways. No thumbs. It's okay. Let's keep going. All right, now C is a half circle. It really is. And I'm going to show that to you on the calculator, okay? C is a half circle, and it goes from -1 to 1, okay? And it really looks like this, and I'll show it on the calculator, but C is a half circle. It looks like this, okay? Oh, kind of missed that one there. Okay. I'll put 1 right there, okay? So let's see it on the calculator, right? All right, y equals clear. Square root 1 minus x squared, parentheses. I've really got to change my window, though. I got to go from like a negative. Let me go from a -3 to 3 and -3 to 3. Graph it. Okay, there it is. You see the little half circle? No, you can't see it. See the little half circle? Okay, so domain. How wide is it? -1 to 1, right? -1 to 1. So domain is from -1 to 1. Okay, there's your domain. And you'll have one like that tomorrow also, okay? These numbers, you listen very carefully, see these numbers? They're the square root of that number. So if this were a 16, it'd go from -4 to 4. Just for 9 to go from -3 to 3, okay? I'm trying to give you every help I can without giving you answers, huh? Okay, ready to turn the page? Oh, I can, Will. There you go. Okay. All right, ready, set, turn the page. Okay, so Landon is running around a 200-meter circular track, and his times have been recorded in the following chart, okay? So let's see what happens to Landon. So first of all, average speed from 32 to 108, so 32 and 108. So I like to circle them. For me, I like to circle them. We did this on Friday, remember? So what we do is we're going to take our y's. We're going to go technically y2 minus y1 over x2 minus x1 for average speed, okay?
Slide it over just a little bit.
Oh, thanks, Marie. So these are my y values and these are my x values because x, y, time, and distance. So we just go to answer the first one. I'm just going to go 600 minus 200, yep, over 108 minus 32. And I'm just going to use a calculator, right? I mean, heck, I like my calculator. So I'm going to go parentheses 600 minus 200 parentheses by parentheses 108 minus 32, and I get an answer of about 5.26, okay? So that's how many meters per second. He's moving along pretty good in the first, but he's going to get tired. You wait and see. He's going to get tired. So 5.26, and that would be in terms of meters per second, okay? It's not bad. Okay. Now, from 203 to 412. So for me, I always erase the last one so I don't get confused, right? And I circle the new one. 203, that's there, and 412, okay? So let's see what happens in the next interval, okay? So we'll do the same thing. We'll take our 1600 minus our 1000 over our 412 minus my 203, okay? This one should be easy. This problem should be easy. Everybody agree?
Yes.
Okay. So let's do it. Parentheses. 1600 minus 1000 parentheses divided by parentheses 412 minus 203 parentheses. I get 2.87. And that's in terms of meters per second. Okay, now you have to be careful because you have to think about the problem. This is not a time. He's covering half the distance. He's going less distance in the same time. He's got to be slowing down. In fact, he's half as slow, right? He was getting 5 meters every second. Now he's only getting 2 meters, but he's getting tired. So it says he's speeding up or slowing down. Why? So we're going to say slowing down because his rate went from 5.26 meters per second to 2.87 meters per second. Okay? That's a good explanation, right? He's slowing down. He's covering less ground in the same amount of time. He's getting tired. All right, number 7. All right, and I'll probably do 7 on a separate sheet of paper so I have more room, but I'll do 7. Okay? You guys see 7? How am I doing? Okay? Everybody's going to be able to do 6 pretty well. 6 pretty easy? Agree?
Yeah.
Okay. There's got to be one easy one on there, huh? Okay, 7. So find the net change. To find the net change, I'm going to go f of 4 minus f of 2. Okay, that's for my net. So in words,